course, what we do about this is we want people who write software to actually think in these terms before their weird machines, their emergent machines, make it out. And so today we have a few themes, a few recurring themes, which I put into questions. And I wonder if we could discuss them. So what do we do? How do we get LangSec closer to software development lifecycle, right? What did make the difference for other kinds of solid software development practices? Pre-check-in checks, right? You don't check in if this looks bad, right? And there are people who try to score code before check-in to tell the programmer, no, you really perhaps should not be checking this in. Are you sure? But can we think of code metrics that are a part of a complete check-in? Breakfast, check-in, right? What role does machine learning play in this? We have heard from two machine learning efforts today, and in both, there is something being learned about the data. Now, machine learning is notoriously hard to use in production, but perhaps the scores derived from it, the metrics derived from it, are just a match, because people try to establish on check-in how much technical debt you might be introducing. What about your data? Data, as we find out, is the destiny of the code. If you screw up your input data format, your code will for sure be unsalvageable, as we saw with the NTP case. And you know, how can we reduce that computing power that we're granting to the attackers? Maybe through some sort of step-down VMs, where you cut out the main Turing complete piece, as Rick was explaining, and then instead of use the VMs as the step-down power, a step-down transformer to protect the rest, to protect that computational power, to isolate the attacker from it. So, who would like to take the floor and pontificate on one of these, or share some ideas on one of these?
No, just maybe I'll toss a hand grenade question there. So, I think if you want answers to these questions, you have to very clearly articulate to developers what guarantee they're going to get out of adopting a particular framework, a particular tool. You know, just as a concrete example here, what benefit am I going to get? And I think actually I thought you asked this earlier. What benefit am I going to get from having or using something like Remo? You know, how is it going to save me? What kind of bugs has it eliminated? What kind of bugs will it eliminate? Right, so, you know, as a developer, those things need to be concrete to me, because otherwise, you are just telling them, hey, use formal methods, and you'll be better and safer. Oh, but formal methods are hard, and it's math, and all those limiting excuses we've heard. So to me, that's kind of the core thing that hasn't been articulated yet. I'll leave there.
I think that this thought is an important one, and to apply it specifically to that first point, and in relation to our discussion earlier about code warnings, I think that any metric we can come up with that is likely to guide us towards good code, but not guaranteed to guide us towards good code, where there's a real possibility that there's a good reason to do things in this weird way, is going to end up creating false positives and more noise and more resistance to conformity to whatever the automated tools are that check code quality, rather than accomplishing our goals. So I think that one of the things that we can work on is if we can say, oh, we want to improve code in this way, we have to come up with a code metric that's going to have a negligible or actually, ideally, zero false negative rate, so that, or a false positive rate, let's say, so that if it ever reports something to a programmer, this is something that's helping a programmer to do what he or she is trying to do, rather than something that is a distraction, or yet just another hoop to jump through, or just another place where I put a comment in so that the code can be exploited later.
Well, the other factor that maybe we should emphasize more is what Doug mentioned earlier in the keynote, and what, for example, Meredith mentioned over coffee, is that frequently doing the right thing is actually easier. So that, using formal methods, you only need 5 people as opposed to 50. Or by writing a grammar instead of having your hand roll copy also, you cut the amount of source code you have to maintain down to a fraction. And these are things that are actually quantifiable, and you don't even need to necessarily make the argument of saying, oh yes, security, everything is going to be scary, but you can say, okay, it's easier in the first place, and you also get security as a nice side effect.
Some of the metrics that people talked about today are also quantifiable. I mean, I think how far does tainted input penetrate into the code base, from Catherine's work? I think it's an incredibly valuable metric. And I mean, if it's something that we can obtain from static analysis, then that's something that can go into code coverage metrics.
You're definitely right that it's easier to do some of these things in the correct way, but the part that doesn't connect with is that the skill required to do that and domain knowledge required to do that is typically a lot higher, and it's a lot harder to hire people that are capable of doing that than it is to hire people that can put together a shotgun parser and make something sort of work enough that they can get it out the door.
Yeah, I mean, just to give a concrete example of this, like I work with people who are afraid of Antler. And they're afraid of Antler because the visitor pattern is one they haven't used very much. Yeah.
And like, I literally dealt with this at work. I trained 6 engineers on using Antler and building code to walk parse trees. And it's, once you get it, it's simple, but it's a totally different way of thinking about things. And it's not something you can easily go and just hire for.
No, to that point, it's not necessarily easy to justify to the management. You need to hire someone specifically dedicated to that job.
That's it.
I mean, they want you to be able to do it with the resources they have already.
Has cryptography solved this problem? I mean, isn't there a mantra that you should hire crypto guys and not try to write your own?
Well,
Doesn't OpenSSL just like
Have
do
you
that
ever
wrong?
been to a
I mean, people still test their crypto code by running it against NIST's test vectors and calling it good.
I see. Cheers.
I think this is a really good point, that it's harder to get people who have these skills, and convincing people to develop these skills is also a difficult thing. But one step in that direction might be is if we could take it, we have these anecdotes of the 5 people replacing the 50-person team. But if we could have some sort of reasonable methodology longitudinal study that's looking at lots of different types of development, lots of different, lots of different languages being developed or being used for development, lots of different goals, and if we could somehow quantify that actually across the board, we actually have numbers, hard numbers, rather than, oh, I know a guy who knows a guy who had this experience, we might actually be able to start making a change. I mean, there's still the fact that people, they feel like it's harder to do formal methods than to do it right.
Well, it is harder, but you have to learn a whole bunch of things that aren't necessarily intuitive or something that necessarily is something you've dealt with before. But once you learn it, it becomes easier. It's a really high cliff you have to climb and a lot of domain knowledge before you can effectively use it.
So the point that Sergey makes is interesting about drawing a parallel to cryptography. One of the reasons I think that we've seen the kind of success that we have in making cryptography a specialized domain, much like we ought to make parsers, is that there have been a lot of bugs that have been very clearly mapped to a cryptographic failing that could only have been seen by an expert in the field. And so I think that certainly things that we've heard today have demonstrated that we have a lot of the tools now at our disposal, even to do things like infer grammars where developers have not bothered to document them formally, which is certainly where the trend is unfortunately heading. But what we need to do is, I think, continue to work on the winning hearts and minds battle that we have, and ensure that when there is a vulnerability like these in NTP, we do more than simply state, here is some vulnerable software, it's extraordinarily funny, look at all the terrible things that I can do, and actually specifically call out which LangSec type failing was responsible for this bug being inducted into the software, and what LangSec tools could have been used to prevent that from having occurred in the first place.
This is very valid criticism, because we've seen a whole lot of things pass by, and we failed to comment on them. So, for example, when OpenSSL was very clearly a parser bug, it took us months to actually make the point. In internet time, this is forever. I must say that I proposed a study like this to the NSF, and when I feel too good, I read the responses.
But like the problem with making like parsers a specialized field is, and like bringing that closer to say crypto, is that there's a lot less crypto that has to be implemented in RIG than there is parsers. Virtually every application has to take input in.
Yeah.
Not every application has to do SSL, or if it is, you can put a terminator on front of it and not write that yourself.
Yeah, no, I mean, I think the hard part is that you don't roll your own crypto code, you use other people's crypto code. You don't roll your own parser generator either. You use other people's parser generators. Right now, people are simply handling their own
But
parsers.
to be fair, like every parser generator I've used are broken at this point.
I do actually have some good news to share, which I forgot about earlier. Excuse me. So Jeffrey Coopery, who gave the talk on NOM, the Rust Parser Combinator Library, couldn't make us this year, but he wanted to share that Videolan is starting to incorporate Rust into VLC. And he's implemented a parser for FLV. It is going in. We are finally starting to ship. So there is that. I mean, we are winning hearts and minds. People are using the shit out of NOM. I mean, I don't know how it took off, but it did. And Rust is young enough that if people just assume that NOM is the default way forward, then we win.
Yeah.
Now, how do we do this in every other language? That I don't know.
Yeah, I was gonna say, how do you get people to use Rust?
No.
I think that there's some amount of mapping these sort of arguments to traditional good engineering practices and like the latest greatest thing of the years past that could be done. Like, so for instance, the step down VMs idea. I hear that and I'm like, it's a domain specific language, and domain specific languages, like developers have adopted them because they take a whole bunch of code that you don't like out of the picture. You don't have to write it. You can accomplish more and more quickly. It's simpler to see what things are doing, and well, if designed correctly, maybe also simpler to validate that it's actually functioning correctly. And so,
Yeah, so one thing that we tried to do with Jacob, who again could not make it, there's something about this date. We've lost quite a few contributors to other venues. There were the famous 10 rules of the JPL, right? Which basically amounted to keeping code simple. And we went through those rules and noted that almost all of them had either a direct LangSec meaning or a LangSec component, including specifics about the use of pointers, right? Which actually amounted to keeping your structures simple enough, right? And avoiding the sorts of problems that NTP has worked itself into by overloading data that controls code, that controls execution. So we should probably, I mean, if you can think of translating a LangSec principle into engineer speak along the same lines, please send us a note. After all, this area succeeds by communicating. And if you have the right adage, if you have the right slogan, we want to hear from you. So, wanted to hear from the people who do work in industry. What would it take to make, say, a language subsetting efforts, a whitelisting efforts, LangSec efforts, and approach whitelisting not as, okay, here is a list or a table, but rather, here is a list that works with other lists in a grammar, in a coherent execution model. Can we hear from industry?
Sure, hopefully I'm not the only one. I think that to the extent that I understand what you're getting at, it's a question of, for one, most penetration testers are unaware of these principles. And so it would be extremely odd for a penetration tester to say, even unless they can find a weird machine, even so much as why is it the case that this input grammar happens to be Turing complete, much less complaining about shotgun parsers, because unless they find the vulnerability, they usually will not write a finding. And so it might be useful to try to work with someone like MITRE to get a CWE assigned if there isn't already one. I certainly couldn't find one when I looked for it last, and that would be the reference database that we would use for what is and isn't reportable. Getting these sorts of things written into standards so that there would be some power to compel one's clients to actually follow this sort of thing in the same way that I can say, NIST has deprecated SHA-1 as of a few months ago, you must stop using it. That's very persuasive, but I can't really do the same thing for LangSec, and so it never ends up being more than an informational level, hey, this is something that you should kind of look at.
So make it a reportable finding.
Yeah.
This is a great idea. You've got a shotgun parser. Basically, should be a reportable finding.
Well, I'm not sure if doing it at a penetration test level might be a bit too late, because at that point, the shotgun parser has already been written, and it's a very, very hard argument to make to say, oh, you should rewrite your software from scratch, because
Well, so the reason I mention it though is that the penetration testing tends to be what drives the development of secure development lifecycle. It does get amended in such a way that it makes it easier for the company to pass penetration tests.
yes. Well, in the industries that needed that. Well, but I think a more effective approach might be to have to get it into a developer mindset that the way you pass an input is you write a grammar for that input. And ideally build the libraries and maybe to some extent make parser generators more approachable, more friendly, go out there, tell people about them, write the tutorials, make the boring build integration, etc. straightforward enough that people will actually do it and that they won't think, oh, I have to open up another Antler thing, but oh, I can read this blog post once on how I use these parser generator frameworks, and from there on I'll just save time every time I write a program.
So we're lacking not only CVEs, but CWEs, but blog posts as well.
Well, or whatever it is.
So on the topic of making these things like reportable or blog posts, like there's a big weight that I can say, hey, follow the secure C coding guidelines from CERT, right? If there were CERT's LangSec guidelines, that would be something that I could point to sort of proactively to developers and say, hey, here's how you sort of avoid a whole class of issues.
And what sort of, Google, I know Google has its own style guide. Probably Cisco does too, right? Do these things get consulted often enough? Is it a good target to try to get into them?
I think the problem with those kinds of lists is they get to be very burdensome. You don't have automated checks that are going to check that you're following those lists. it's hard to keep that in the developer's mind when they start every day. They have to, they're putting on a list of like 50 items that they have to remember throughout the day.
Well, typically, a linter is set up just to verify that, but they don't go and reference like document. But it's how do you write a linter for finding shotgun parsers?
Yeah, linter for
verifying-
LangSec. Well, so what we've heard from
Well, yeah,
Catherine was,
First steps towards
Yeah.
that kind of thing first.
In my experience, those internal sorts of coding standards documents are authoritative at companies that have a mature secure development lifecycle, which is really the only place this battle is winnable. With that said, yes, it is the case that it tends to be those rules in those guides, and it's not just style guides, it's also secure development lifecycle coding requirements. Those rules that are amenable to linting happen to be the ones that get enforced, and the other ones it is up to the code reviewers to say, hey, there's a violation of this, assuming that they understand the subject area well enough to actually notice it. And it's a list of perhaps 300, 500 individual requirements, each written in abstract language. It can be very, very, very painful. If there were some way to use the taint tracking that we have, work it into a static analysis tool similar to Coverity, then you could end up with a scenario where it's necessary for developers to, at the very least, write a comment that says, I'm bypassing this check, and then we'll have a mine for these sorts of things. But that would be the practical consequence. But all of these things would work to drive developer awareness. These guides are usually mandatory reading, and they are well followed.
so I'm hearing that it should be a part of a complete checking.
Yeah, absolutely. There's no other way to do it. Nothing
And I
else.
think most of the big industrial places are doing this.
Except not for LangSec.
What?
Except not for LangSec.
Nothing like, yeah.
Out of curiosity, are any of these included in the standard libraries of languages? Like everybody has to do LangSec. Why is it
Scala.
just okay?
Really?
Yeah.
There's a parser computer library in Scala standard library.
Rapid as well.
Rapid.
Rapid ships
Yeah.
with parser combinator, electric combinator.
Nice.
But I mean, Rapid's all about designing the language you want to program in and then programming in it. So it kind of stands to reason.
It would be interesting to see if it's possible, certainly not in C, but in C++, to get some kind of extension to the standard library done up.
The process is you write a paper and you make the case to people.
Yeah.
And from the ISO C++ committee members that I've talked to, their main issue is just that no one is willing to sit down and write a paper. You have to write technical English and write however many pages of ISO standards English you want to write.
Well, and boosted spirit is totally a thing too. Yeah.
And I mean, that is authoritative as well. If I, as a penetration tester, am doing a white box review on code and I find that they have re-implemented, as I often find they have, stir copy or something like this, if it's in the standard library at all, I say, why on earth did you write your own set? Please strip this, throw it in the garbage, and use the standard one. And I don't even need it to be exploitable to say that. It's just a question of attack surface.
And one thing you could do if you have it in a standard library, at least widely accepted, is you could also change your I/O libraries to enforce parsing at I/O time. So you can say, okay, well, raw byte I/O in itself is not necessarily is a deprecated or potentially unsafe API or whatever. The way you do input/output is you have a file object and you pass it a parser, and you either get back an error or
So make a CWE for raw byte I/O.
Yes.
Where in fact, oh yes, that's. I mean, Haskell arguably does that, but then of course,
well, it doesn't have side effects.
it doesn't have industry following all that much.
Depends
but-
on what street you're hanging out on, but yeah.
No,
There are corners of the world where Haskell is very popular.
So let's see. Bad extension points. Bad extension points. How can we burn them? I mean, can we say just don't use HTML in XML entities? Let's save XML, right?
To a large extent.
Who does?
Actually, we usually just say don't use XML.
Well, we say that too, but I mean, currently XML entity, external XML entity inclusion is generally viewed as a problem, and there is a one command thing that you can do to initialize your XML parser for virtually every standard XML parser that just disables these things point blank.
This reminds me of IPv4 options, which were seen as standard and indispensable, and now are pretty much, I mean, the only place you see them is IDS signatures, right?
Yeah.
And with block this packet. So wouldn't it be nice?
I think it really comes down to creating better alternatives that people want to use instead of this.
Yeah.
Eventually it gets removed. I mean, like, you look at like SQL injection, and it will never go away so long as you still have SQLs by nature of the spec.
So keep hammering, right?
Yeah.
Yeah.
I think this is an instance where it was somehow perceived that you need the extensibility that these things give. And for instance, having parser combinator libraries or whatever more powerful ways of building proper parsers kind of gives that or presents that option, that better option that you mentioned of doing things, because suddenly you can afford to roll your own, so to speak, language, make a specific language that has the power that you need, instead of saying, oh no, I can't write a parser, for God's sake, I have to take XML and extend it with some crap.
But even when you start bringing in, like say, a parser combinator into it, like which algorithm do you use? And then if you're writing different languages, you have to understand the algorithm enough that you can say, well, I know I have to write my grammar this way because I know it's going to handle this ambiguity in this way, or it's going to handle any case in this specific way.
Well, yeah, but that's, I'd say that's, I mean, you always have to deal with particularities of your system, but one point is that, which we did with Hammer, is that we have multiple backends, and it'll use the most general one that it needs, basically. At that point, this gives you the nice ramp where you can just move up and down by modifying your grammar, and it's not really complicated anymore.
The story about SQL injection is certainly an interesting one too. The reason that this is no longer as much of a problem as it has once been is that the mitigation is trivially easy. We managed to transition over the past decade-ish from SQL query construction by string concatenation into almost exclusive use of bound parameters in new applications, and frameworks like LINQ and Microsoft's .NET method of doing data first, or sorry, code first database schemas where it will infer all of your SQL for you. But many programmers find these things easier to use than SQL, and now they're all afraid of writing SQL, which is exactly what one wanted. If we could find a similar thing to leverage, that would be effective. But unfortunately, we have parser generator tools like Lex, which most people are deathly afraid of because the syntax is arcane and Unixy.
I would not say that it is Unixy. I would say that it is just arcade. Well, you know, having N authority on Unix.
It's a little old.
But it's still difficult to use and intimidates people, and that was his point, he's right about that.
Yeah, yeah.
But there's better tools, and I mean like Antler, it makes it trivial to, I mean once you understand how to write the grammar, it
Right.
gives you a tree afterward, and all I have to do is know how to walk it.
Right, well, Racket has a great one. It takes a little bit of reading the docs before you realize, oh, I'm gonna create an S expression description of my lecture. Once you get it, it's great.
Well, we always knew that Lisp would someday come back and save the day.
Did you say nobody? Nobody knew? The listeners would disagree, I'm sure.
Well, we knew, at least.
No, I mean, I would say that even there you have the issue, you need to understand what a Lex is in the first place. And sort of, you have the issue with parser ambiguities that you need to understand how your parsing algorithm works. And this seems like a very leaky abstraction because
Yeah, exactly.
The average industry developer probably knows that there are different parsing algorithms, but you don't want to keep them in your mind all the time while you're writing a program.
Well, and it works really well.
Even if you do keep them in your mind, you still might run into the situation where you should be self-different somehow.
Let's be honest, I don't keep them.
Oh yeah, no, I mean, I wrote an also generator and I got a systems paper in for it, and I still can't explain it all to you without pure code.
And like it makes like sense, and it's easy if you have like simple grammars. But as soon as you start doing anything complex, like that's where it becomes like this insurmountable problem. And unless you really know what you're doing, it's just unattainable.
So to this, I would respond that it seems that, say, when Google started its protobufs, they specifically limited the syntax of those messages to context-free. And not very, I mean, and really perhaps a subset of that. It's just that they did not say the words grammar, but the way you construct those serializers and deserializers, they are essentially combinators. And these combinators are very, very few. And of course, I'm sure that people do unadvisable things like create dependencies between objects that are so encoded, and then rely on those dependencies being there without actually verifying them. But the core language of protobufs makes it very, very hard to actually encode anything that's serialized, at least at the core serialized thing. Yes?
But one of the reasons protobuffers are useful and actually have some traction is because a lot of the time I'm a programmer, I'm thinking, oh, I'm going from an object that's native to whatever language I'm using, and I need to somehow write this to a disk or send this on a network or something, and oh, there's this definition for how to do it, and there's already a library for it. All I have to do is make it a protobuffer, and whatever language I'm using, there's already something there that makes it really easy for me to solve this problem, and I don't have to think about the serialization.
So you're saying that this is not a language for them. This is for them a type. A type that intuitively
It's a type or it's a library or something,
a type in the true sense, right? In the Hindley-Miller sense, for example.
Sure. But what I'm getting at is simply that we're making that the protocol buffer, by virtue of the software, the support software that's been written for it and made available with bindings for lots of different languages, makes it so that it actually is easier to solve the problem in a way that's visible to programmers than doing it on their own. And the real success, if we're trying to get people to say, oh, I need to deal with some sort of language, I need to come up with reading a file and making sense of it or something like that, then we need to actually get our parser combinators and related tools to be easy enough to use, easy enough to put into whatever coding environment people are using, that they really can say, oh, the easiest way for me to solve this problem is to pull up Antler or pull up, name whatever the tool is, and have it solve the problem for me.
So yeah, Hammer's about halfway there because it's got bindings for like 8 different languages, but it kind of sucks at generation still.
So maybe
So there's Dale, right?
Well, yeah, no. Well, that's one thing.
But Dale
Maybe
doesn't have
one
one.
trick to do is instead of generating native data types, generate protobufs, because
You
there
know,
are lots of
that's
people
not.
who have bindings for everything. I pay people a lot of money to build the bindings, and if you don't.
I think there's a relevant thing that was brought up, and that is that developers will use whatever thing that they have that is easiest. And right now there are language-dependent serialization forms that are designed to go from a binary to a full-fledged domain object of an arbitrary type in the system. And that is a fundamentally dangerous primitive that
Ruby on Rails learned it the hard way.
So Ruby on Rails has had this problem with YAML, Java has had the problem with Java serialization, Python has had it with Pickle. Every single framework that does this has had problems because the entire point of that interface is to take a string from a presumably trusted source and execute it in the VM. I mean, it is remote code execution in a single function call. So we should make it as horrifying for developers to use that as to compose an SQL string using the concatenation operator. So what I'm hearing is hide the language behind the library, make that library create types that map well to the data types, but not to the system types. Yes, and in particular, do not use any serialization format that can serialize or deserialize an arbitrary object.
So my question is, how are we going to get out of JavaScript the ability to evaluate a JSON object in order to parse it?
Well, it either learns the way.
That's a really, really easy way to solve the problem. Oh, I just read a JSON object off the network.
Ruby on Rails did the same thing. Parsing is hard. Let's eval. It became known as Ruby off Rails for that. JavaScript, I can't even begin ranting about it. But maybe, I don't know, does Node.js encourage that or discourage that? Or is it agnostic?
There's a lot of really dumb people writing it.
Someone who truly, you also have to sort of set a certain minimum standard for developers at some point. Like if you really...
We're not getting anywhere near that right now.
No, I know, but say with JavaScript, there is by now tooling, and at least larger JavaScript projects are tending towards things like CoffeeScript and TypeScript, where they have types. And those will actually, by default, because they've learned it the hard way, prevent JCP eval as an eval buffer without making you jump through hoops.
Oh yeah, that's right. Just basically in the next framework, in the next fashionable framework, just make eval do something else.
Throw a warning at least.
There's a point to be made about the fact that JSON was specifically designed to be parsable by eval. So,
well, but that comes out of sort of a weird history with the way browsers used to fetch things, and then you have to insert a script tag.
yeah, but
That's a sad decision, but
These things of convenience are what SDL is designed to reverse. And so by making these things reportable and ensuring in those places where the company is actually following an SDL, the developer's first objective is to make their manager go away by making the code work, but their objective following that is to make the penetration tester go away by rebutting all of the bugs. And so if I have something that I can point to and say, and I can already take, hey, you just evaled, user provided data. That is always reportable today, and anytime that it happens, I can always hold the program's release hostage until they get rid of it. If we simply make everything else like that, then at least in those companies where this incentive is created, it will work. Because you can't force the developers, if they're not willing to think about security, to do so. They don't already in any other arena, unless there is a secure development lifecycle they're working in.
So you just eval user data, but of course any input data is a program, and
I think.
but this is a very good point. Yes.
I think in a certain sense, a lot of these issues that we're discussing just in the last few minutes are, I'm afraid to say, but already kind of solved. Like you say, eval, you can hold a release hostage for it, even though people will still make the mistake. But we've also heard that parser combinator libraries are crazy popular in some circles, and I think the fact that they aren't in some others may simply be due to the fact that, I don't know, these things propagate or something, or it's a historically grown ecosystem more so. Ecosystem is maybe a keyword because programmers use what's available or what's common or what's fashionable even in their ecosystem. So And that was one of the motivations behind Hammer, right? To simply establish a tool for a C-centric ecosystem. In my mind, the problem then becomes more one of making sure people find the languages and the parsers that they should be implementing in the first place. Because it's easy to say, oh, here's you're pulling in a file here, or you're pulling in a network packet there. You have to parse that somehow. Where's your parser? That's something that's also easily audited, right? You say, hey, what does your parser look like for this packet format? I think a very interesting future direction is to just try to find out where are the languages hiding that are beyond the parsers. And I forget where, but we've seen this somewhere during the day about what complexity is hiding in the interactions inside the program. So. And I think that feeds back into having the inventor of Unix pipes sitting next to me, into the decomposability thing, and also your talk with the flow graphs. One of the things we had with the DMP3 parser was the clear separation between the input handling and the rest. We want our programs to basically look like these strings of bells or whatever. So you have just one edge that goes from one part of the program to the next. If it's a pipeline of things, it's nice.
So it's an interesting note to finish on. We started with Unix pipes and a composability that allowed the system to flourish. Well, perhaps we can reboot the ecosystem by creating better pipes that will allow the ecosystems that are stuck in that kind of poisonous complexity to reboot themselves.
I definitely really like the idea of getting additional coding standards into the hands of folks like you. Let's talk about that more soon.
Mm-hmm.
I would appreciate it, and I might be of some help. There are some people I can engage that.
SecDev is coming up. It's a new thing devoted primarily to security development. They solicit 5-page papers on various security development methods we intend to submit, but just a word to other interested parties.
Where is it?
I believe it will be in Boston. The deadline is on June 22nd, I believe. So this may be a place to have a strong LangSec show. So we're coming up on the end of our time. I would like to thank you all for coming. Of course, if it were not for you, we would not have a workshop. Thank you very much. And let's hope that we'll keep growing.
Thank you for coming.